right, so we're going to go ahead and take a look at mathematical induction. And this is your first proof that involves all real numbers. So, first statement, show the statement is true for some integer n. So let's go ahead and look at what we're going to try to prove. We are going to try to prove that 1 plus 2 plus any set of numbers all the way up to n is equal to n times n plus 1 over 2. This is what we're trying to prove. Now, so what we're going to do, is this true? Is it true for n is equal to 1? Well, that would just mean 1 is equal to 1 plus 1 over 2, and that will give me 1 over 2 over 2, so yes, that is true. Now, the second step, step 2, assume this is true for some other positive integer k. All right, so really all you're doing is you're just saying that over again, but now we say that is k. And this is our induction hypothesis. Now, this is where it's tricky. Show the statement is true for k plus 1. So this is substitution, but on two parts. Now, I am saying that all of this here is equal to this piece, right? So keep that in mind. Now I'm saying this would be 1 plus 2 plus k plus 1. All I've done is added a second term right there. So if all of that is true, now I also go through and wherever I have k on the other side, I change it to k plus 1. So now all of that equals k plus 1 times k plus 1 plus 1 all over 2. Now, the substitution part. Since I know all of 1 through k is equal to this, that's the trick. That's the substitution piece. I go ahead and replace that. Is k times k plus 1 all over 2. And remember, that's just equal to all of this. 1 summed up to k has to equal this, so that comes down. Then I go ahead and say plus that k plus 1. Does that indeed equal k plus 1 times k, add those two together, k plus 2 over 2. All right, so that's our question mark. We don't know. The way we're going to go ahead and show that is we're going to go ahead over here on the left-hand side, find a common denominator. So I'm going to make that times 2 over 2. All right, so if I multiply all of that out in the numerator, I have k squared plus k plus 2k plus 2 all over 2. And then I have k squared plus 3k plus 2 over 2. And if I factor that, I get k plus 1 times k plus 2 is 2. So yay, I'm done. It is true. All right, so let's go ahead and prove this statement. Is 5 plus 11 plus 17 plus ... all the way up to 6n minus 1. Does it always equal 3 times n squared plus 2n? All right, we go back to step 1. Show this is true for any number. So we just start with n is equal to 1. When n is equal to 1, that would mean does 5 equal 3 times 1 squared plus 2 times 1? And yes, 5 does equal 3 plus 2. All right, so step 1 is done. Step 2, assume this is true for any positive integer k. So that means 5 plus 11 plus 17 plus ... all the way up to 6k minus 1. And this is my induction hypothesis, and therefore we're going to assume it is true for 3k squared plus 2 times k. Now, step 3. And step 3 is the tricky part, remember? So what we're doing now is we're saying 5 plus 11 plus 17 plus all the way up to 6k minus 1. Now, in this case, I'm adding on 6 times k plus 1 minus 1. Does that equal, and then everywhere I have k, I change it up here to k plus 1. I'm going to run out of room here. Just going to make this a little bit smaller. So does that equal 3 times k plus 1 quantity squared plus 2 times k plus 1? Now, let's go back to what we said we assumed was true, our induction hypothesis. Our induction hypothesis says all of this is equal to this. So we're going to go ahead and replace again. All of this is equal to the sum over here. So now what that leaves me with is 3k squared plus 2k plus 6 times k plus 1 minus 1. And I have to prove all of this is equal to 3 times k plus 1 quantity squared plus 2 times k plus 1. And if I prove those two sides of the equations are equal, then I've completed my proof by induction. So let's go ahead and take a look how we're going to do that. I'm going to go ahead and start by multiplying it all out. That gives me 3k squared plus 2k plus 6k plus 6 minus 1. And if I go ahead and combine like terms, that gives me 3k squared plus 8k plus 5. All right, does that equal the same thing on the other side? Now, you can't really go through and work on both sides of the equation. What we can use is this working backward trick. So if I go ahead and start down here and say that I think it's going to end up as 3k plus 1 squared plus 2k plus 1. And if I can get that, it works. So let me go ahead and multiply this out. So that would be 3 times k squared plus 2k plus 1 plus, and that would become 2k plus 2. Distribute the 3, and I get 3k squared plus 6k plus 3 plus 2k plus 2. And lo and behold, I get exactly the same thing. That's 3k squared, the 6k, that should have been k, and the 2 give me my 8k and my 3 and my 5. So you have technically only touched one side of the equation. But that working backward trick is very helpful. All right, we're going to do one more, and I like this one because it's the sum of all of the odd numbers is equal to the last number squared. So let's show it's true for n is equal to 1. So is 1 equal to 1 squared? Yes. All right, so just to do one more, just to show you, if it was 1 plus 3 plus 5, does it equal 3 squared? And just remember, it is 3 because this is n is equal to 1, n is equal to 2, n is equal to 3. And it does. Definitely 9 is equal to 3 squared. So we start with the assumption step, which is that 1 plus 3 plus 5 all the way up to 2k minus 1. Does that equal k squared? Now we assume it's true for k plus 1. So I do the same thing again, only now the 2k minus 1 is not my last step. Now I also have to add on that plus 2k plus 1 minus 1. That's my last term. Does that equal k plus 1 quantity squared? And again, all I'm doing is wherever you have k, replace it with k plus 1 in those last two pieces. So all of this beginning piece is equal to k squared. I bring down the plus 2k plus 1, and I'm trying to show it is equal to k plus 1 quantity squared. Multiply this out, and I get k squared plus 2k plus 2. And indeed, when I factor that all out, it is equal to k plus 1 quantity squared. Let's go ahead and look at another one. 1 plus 4 plus 7 plus all the way up to 3n minus 2. We're assuming we're going to prove it is equal to n times 3n minus 1 all over 2. So step 1, assume it, prove it's true for n is equal to 1. So does 1 equal 1 times 3 times 1 minus 1 all over 2? And yes, 1 times 2 over 2. All right, so the second part is to go through and assume it is true for k. So that's 1 plus 4 plus 7 plus all the way up to 3 times k minus 2 is true for k times 3 times k minus 1 all over 2. Now, next step is to show all of this is true for k plus 1. So it's 1 plus 4 plus 7 plus all of this plus 3k minus 2. And then I have to add on that k plus 1, which is 3 times k plus 1 minus 2. And again, all I'm doing here is wherever I had k, I add 1 into that, so it's k plus 1. And I do that on both sides. So on the other side, it is k plus 1 in parentheses, and then 3 times k plus 1 minus 1 all over 2. Now, I'm taking all of the piece that I have in blue and replacing it with the sum that I think it is, which is k times 3k minus 1 over 2 plus 3 times k plus 1 minus 2. Does that equal everything over here, which is k plus 1? And you're allowed to simplify over here. That would be 3k plus 3 minus 1, or 3k minus 2 all over 2. That's what we're trying to prove. That's our big question mark. So I need to go ahead and find a common denominator. So I'm put a 2 out front here and everything with a 2 there. And let's see what we got. If I multiply this, I will have 3k squared minus k plus 6k plus 6 minus 4 all over 2. And what I did here, this was just 3k plus 3 minus 2. And then I just distributed. Now I'm left with 3k squared. I combine my k's plus 5k plus 2 all over 2, which when I factor it is k plus 1 times 3k plus 2 all over 2.